Hello everyone. In this mini lecture, we're continuing on with the concept of exponential functions. So within learning exponential functions, we move to an area known as compound interest. So this is a real world application that we see every day. The formula for compound interest is as follows. It's A is equal to P times the quantity of 1 plus R over N raised to the T times N power. So compound interest. This formula states that if P dollars are deposited, so P is the present worth or present value, deposited in an account paying an annual rate of interest, which is represented by the R. The R must be written as a decimal. So they'll likely give it to you as a percent in the word problem, but you'll write it in your formula as a decimal. So you just change from percent to decimal and you're good. And this interest is compounded n times per year. And again, likely the word problem will tell you that it's compounded, maybe let's say quarterly. If that's so, you'll say 4 times per year. Or they may say annually, so that's only once per year. So you have to pay attention to the wording of how many times they say that the interest is compounded. And then after T years, so that's in years, that's the amount of time that the money is inside of the account. And then the account will contain A dollars. So A is the future worth, how much money is in the account or how much you've made after a long period of time. So the formula will help us solve the following examples. First example, using compound interest. So suppose $1,000 is deposited in an account paying 4% interest per year and it's compounded quarterly. So we're asked to find the amount in the account after 10 years with no withdrawals. So the first thing I would do is write down all of our variables and see what's given and what we need to solve for. So A is the future worth. Well, that's unknown because they're asking us to find the amount after 10 years. So A is unknown. Now P, the present value, right? That's the present value or the present worth. Looks to be $1,000, right? That's how much we deposit into the account. The interest rate, the R, it tells us is 4%, so we change that to 0.04. So for changing to decimal from percent, we just move the decimal place over 2 places. So it's really 4.0, so we move it over 2 places and we get 0.04. Next is our N value. So our N is how many times it's compounded yearly. Well, it tells us that it's compounded quarterly. So quarterly means 4 times per year. And then T is the time in years. So this is the time, which is 10 years, as stated. All right, so now it's just a matter of going ahead and plugging into the formula. The formula was A, which we don't know, is equal to P, which is the $1,000, times the quantity of 1 plus R over N. R is 0.04 over N, which is 4. And this is raised to the T times N power. Well, our T is 10, our N is 4. All right, next we'll just do the arithmetic that's involved. So we have 1,000, and of course we have to do what's in the parentheses first, and I know that 10 times 4 will give me 40 there. So 1,000 times the quantity of 1 plus, and now I'm calculating the 0.04 divided by 4. 4 hundredths divided by 4 gives us 0.01. Alright, so now taking that and doing what's in parentheses still, I get 1,000 times the quantity of 1 plus 0.01 is 1.01 raised to the 40th power. According to order of operations, we need to do the exponents next. So we have 1,000 and 1.01 to the 40th power. Punching that into your calculator should yield about 1.4888. And then 1,000 times 1.4888 is 1,488. So, therefore, it tells us that the amount in the account after 10 years with no withdrawals will be $1,488. $1,488. So the next part of the question, part B, says how much interest is earned over the 10-year period. So we just currently calculated that after 10 years we will have $1,488 in the account. In calculating the compound interest, this is what we'll have. Initially we deposited $1,000. So therefore, the difference between the two amounts is how much interest is earned over that time period, which is the 10-year period. So all we need to do is take the difference of those two values, and that gets us $488. So this is the amount of interest that we've earned over the 10-year period. Next example, finding the present value. So our example says that Denise must pay a lump sum of $6,000 in 5 years. So part A says, what amount deposited today at 3.1% compounded annually will grow to $6,000 in 5 years, because that's what she needs. So let's go ahead and take a look at what we have for each of the variables. Our A is $6,000. Right? That's our future worth. That's how much we need in her account after this amount of time. So that's what we're shooting towards. Our P is our present value. That's what we're trying to figure out. How much Denise needs to invest or put into the account so that it can build to that $6,000. So that we don't know yet. We're looking to find that out. The interest is 3.1%. So moving that decimal point over 2 places to the left, we get 0.031. Next, the N value, how many times that interest is compounded. Well, it says annually, so that means once a year. So our N is 1. And then T is the total amount of time in years. Well, it's going to be 5 years for Denise. All right, now inputting everything into the formula. So the formula had the A is equal to, so 6,000 is equal to P, which we don't know, we're trying to figure out how much she needs to invest, times the quantity of 1 plus 0.031, right? That's the R over the N, which is 1. And this is raised to the T times N power. So our T is 5, our N is 1. Working on the arithmetic here, we get 6,000 equals P times the quantity of 1 plus 0.031 raised to the 5th power. And now I'll just go ahead and add what's in the parentheses there. So P times the quantity of 1.031 raised to the 5th power. Inputting that into my calculator, the 1.031 to the 5th power gets us 1.159. All right, and now solving this algebra problem, we need to get P by itself. So what I would do is just go ahead and divide, right? Divide both sides by 1.159. So for us, P is equal to 5,176 after performing that division. So this tells us that Denise must invest or place into the account today $5,176. If she does that with a interest rate of 3.1% compounded annually after 5 years, she'll get the $6,000 that she needs to pay for whatever it is she needs. Part B of the problem says if only $5,000 is available to deposit right now, what annual interest rate is necessary for the money to increase to 6,000 in just 5 years? All right, so again, what I'm going to do is write down all the variables and see what we have. So we have A is 6,000, that future worth that she needs, $6,000. Our P is 5,000 because that's all she has to invest right now, just a flat amount of 5,000 bucks. We're trying to figure out how much the interest rate needs to be. So maybe we're trying to figure out which type of account or which bank or which investment to put it in so that in 5 years she'll get the $6,000. So we need to compare maybe some institutions and then figure out what's the best interest rate for us. And then the N is equal to 1 because it says compounded annually. And then the time is 5 years. So we're solving for R, the interest rate. How much does the interest need to be for her money to grow the way she wants it to in 5 years? So I'll just substitute in. We have $6,000 equals 5,000 times the quantity of 1 plus R over 1. Right? So 1 was in the formula. The R is what we're trying to solve for, so we didn't plug in anything for the R this time. And the N value is 1 because it's compounded annually. And that's raised to the T times N power. So that's 5 times 1 power. All right, so we get 6,000 is equal to 5,000. And that's 1 plus R raised to the 5th power, right? Because R over 1 is just the same as saying R, and 5 times 1 is just 5. All right, so here what I would do, since we're solving for R is within the parentheses, let's move anything that's in front of this set of parentheses. So we'll just go ahead and divide both sides by 5,000. This cleans it up a little bit more for us, so then we don't have anything in front of the parentheses here. So 6,000 divided by 5,000, putting that in our calculator, we get about 1.2, and that's equal to what we have here, 1 plus R raised to the 5th power. All right, for this part, we need to somehow break this down a bit. So we see that the 1 plus R is raised to the 5th power. So we think back to some things we may have done in algebra, and that's dealing with radicals. So what we'll do is, for both sides of the equation, we're going to raise both sides. I'm sorry, not raise both sides. We're going to take the 5th root of both sides. Take the 5th root of both sides. So this will help us a lot because on the right hand side, if we take the 5th root of something raised to the 5th power, that's just going to leave us with the radicand of 1 plus R. And then we take the 5th root of 1.2. So you plug this into your scientific calculator and you'll get 1.037. All right, and now just solving for R, you just go ahead and subtract 1 from both sides. Right, so R is equal to 0.037. So thus the interest rate must be, we're going to move that decimal point 2 places to the right to make it a percentage, 3.7%. So she must take that $5,000. If she wants $6,000 in 5 years, where it's compounded annually, she must take that $5,000 and put it into an account that gives a rate compounded annually of 3.7%. All right, so I hope those problems helped you dealing with compound interest. If they did, please feel free to hit the like button, subscribe, and share with anyone else who may need it. Thanks and have a good day.